This is the first video in a series of me building a nuclear fusor, or farms with fusor. For a little background, a nuclear fusor is a class of inertial electrostatic confinement reactors. Simply put, a high voltage, usually in the several tens of kilovolts range, is induced between a metal grid inside a vacuum chamber, accelerating positive ions toward the grid with enough energy to fuse. Fusors are pretty popular with amateur nuclear engineers like myself because they're relatively simple to build compared to other fusion reactor designs. I'm using a common design of aluminum flanges and borosilicate glass tubing as the chamber. I'll explain more as we go along. What I'm doing now is cutting some alumina ceramic tube for the high voltage feed through. A 2-inch threaded rod goes through the middle of it and carries the voltage to the inner grid. A diamond bit cutoff wheel is used to cut alumina. I picked up a pack of them off Amazon for $9. However, as you can see, it was still quite difficult to cut it. Using a vise would be ideal here, but I don't have one. The thing that I am clamping the ceramic tube to is the bottom flange of the fusor, and this is the aluminum bar stock that I took to a machine shop in my town, and I got machined for about $10 using their drill press. So there's 4 holes on the outside for threaded rods, and then 1 hole on the inside for the feed through, which is on screen now. Cut and done. So now I am hammering the stainless steel feed through, and that is going to go through that metal hole in the bottom flange. And so what I'm doing now is using some 2-part 24-hour epoxy resin and putting it inside of the feed through hole, and once that sets, it'll keep the feed through in place and also keep an airtight seal. And a quick word about using epoxy as a sort of adhesive with the fusors. You want to be careful when you're using them on the inside of the vacuum chamber, like I am. Make sure you're using an epoxy that's like at least 24-hour cure, because apparently this type of epoxy off-gases less inside of a vacuum. And if you have tons of off-gassing, you won't be able to pull a proper vacuum, and the fusor won't work properly. So there I am, putting the feed through the hole. I'm supposed to have uh, about half an inch poking into the inside of the chamber, and the other side will be connected to the high voltage output, and that stainless steel feed through will send the power into the inner grid, which I'll show in a bit. So here's the bottom flange set up on 2 cups to let the epoxy set with the feed through. And here is what I'm going to be using as my high voltage grid. You'll see it's just a sort of whisk ball that I've attached to a 1032 screw with 2 washers, a hex nut, and 1032 screw. And this was a way for me to get around having to use silver solder and having to fabricate my own grid. Like most fusor designs, I just really didn't feel like working with something as dangerous as a blowtorch. So that's why I went for this grid design. And this is the grid attached to the high voltage feed through. And that little whisk ball is where we'll see the current discharge. Uh, yeah. So the next order of business is to tap the top flange with threads. And I picked up a tap set as well as a T-wrench to use with it. Only problem was the taps did not fit in the T-wrench, so I had to use a electric drill, which is usually not recommended for tapping. Tapping the holes were quite difficult as the electric drill just went too fast to get a decent thread, and I ended up just having to only screw in the components, I guess partially in, and then seal them with epoxy. So that's what I'm doing with the vacuum gauge now. I'm screwing it as far as it'll go, and then I'll just apply some epoxy resin to the outside of the hole to make sure that it's airtight. And so here's the finished top flange. You can see there's a vacuum gauge and a barbed hose fitting, and that is a 1/2 inch NPT pipe thread to 1/4 inch barbed hose fitting, and that'll go straight to the PVC vinyl tubing that goes to our vacuum pump.